help if I had my mouse set on, of course. There we go. Great. Oh, hi, Brent.
How are you doing?
I'm good. Great to see you. So we're going to look at some information about statistics, just really brief, but also trying to give you some terminology to look for to help you out, because I know a lot of you have not had a statistics class, and sometimes just by knowing the right words to look for in that data analysis or results section can help you out quite a bit with understanding. So I thought we'd just go over a little bit of that. And then if anyone's got any questions about anything, I know ANOBIB 1 is due, is that tomorrow it's due or Monday? Maybe Monday, I can't remember. So if anyone's got any questions about that annotated bibliography or anything like that, then we can deal with those as well, okay? Oh, and just before I start, as I've mentioned before, I am not a qualitative researcher, and I've never had a class in qualitative research, so I don't feel at all inclined to do a class on qualitative data analysis, but I do have a chapter out of a qualitative research book, and that is up in that week 9 folder, just in case any of the articles you're looking at are qualitative. There's some additional information to the info that Dr. Berkey covered in the lecture on qualitative. All right? And I am going to stick with my quantitative that I am woefully out of practice with, but at least I have a decent understanding of how to tackle that. So we've mentioned the first couple of points here before, right? The initial step when you're going to look at a research project is, what's the question that I'm interested in, all right? And when you can narrow down the question that you're interested in, and that in itself can be quite difficult, because once you start looking at information, there's so much stuff that's fascinating. I mean, I could literally retire tomorrow and spend all day reading for the next 10 years. You know, I mean, there's just so much interesting information out in the world. So narrowing down that question is step one. And then after you know what your question is, then you can start to think about, well, what kind of data am I looking to generate to answer that question? Do I want interview type data, and then it's likely to be more qualitative? I'm going to be asking people about what they think about things, right? Or do I want something that's very numerical with distinct number data that I can then play with, all right? So if it's the quantitative style, then we want to know what type of data we have, we want to know the level, and we've got to remember those classification of our variables. So when we have quantitative data, these days, so when was I in grad school? I graduated in 2015. from grad school, and I took one statistics class that made us do everything by hand. We had to calculate everything by hand. It was a nightmare. It's a nightmare of a class. But mostly, even with qualitative, there's software now to help you organize all the questions and all the answers and the transcripts and everything. But in quantitative, there's many different statistical packages now that you can use. And it really doesn't, as far as I know, and I'm talking off the top of my head here, but I was trained to use SPSS. That's a very popular statistical package. There are many others. But as far as I'm aware, I mean, a statistical analysis can only be done a certain way. So if I'm going to run a t-test and look at the correlation between two variables, whether I run a t-test in SPSS or a t-test in 5 other pieces of software, I should get the same answer because they're all doing the same calculation on those numbers. Okay? So that's why when we were doing the summaries before midterm, I said you don't need to, as a key highlight, the statistical package isn't important. If I'm writing the whole article or the whole paper, do I have to tell the reader which statistical package I used? Yes, absolutely, right? But it's not a highlight, right? So when we run that, then we always get descriptive data. Is the first block of data that comes out, spewed out on the printer. And you get pages and pages and pages and pages. So the first few pages are descriptive. So what that does is it pulls together characteristics of your data. So if you have identified males versus females, it will tell you how many males and how many females. If you've identified their age, it will tell you their age and give you a mean age for the group. And you know, that kind of information, all right? So you always get that first. And then what we're looking for is, generally we're either looking for differences between variables or relationships between variables, right? So in quantitative research, that's generally what we're after. So, first document that you want to take a look at is my cheat sheet, which I've scanned in for you. And I have to say a big thank you. I try to remember every semester to say a big thank you to my stats specialist who helped me with my thesis, with my dissertation, and then I also took a couple of classes with him. Dr. Guarino, he was one of the stats faculty at Auburn, and he gave us this cheat sheet in class. So I don't feel guilty for using it at all. And it saved my life when I was doing more research and when I was reading research. So the first thing you have to remember is the difference between the independent variable and the dependent variable. All right? If you're doing a quantitative study, if it turns out your study is qualitative in nature, then they don't typically identify variables in the same way that we do. All right? So remember that my dependent variable is my variable of interest. Okay, that's the thing. I want to know what happens to this. When I do this, and that's the independent variable, right? So the independent variable is the thing that we're manipulating, and the dependent variable is the factor that we want to know about, all right? So that's important to remember when you look at the cheat sheet, all right? Because you're going to go down to the kind of second block of information here, and what it does for you is if I can define the independent and dependent variable, then the cheat sheet will tell me which statistical analysis is appropriate to run. So I don't even have to understand stats well enough to work out which button to push on the software, right? It's great. Now, if you are really a stats person, like if you go to the math department and you talk to their statistics specialists, they probably have the heebie-jeebies about this approach, right? But we're not statisticians. We're HPE people, okay? So we can bend, it's not bending the rules, it's just kind of taking some leaps and not learning the whole job, right? But it really helps with the reading and the understanding and then the writing of if you have to write any statistical information out for your other classes, okay? So the first thing to do is to look at the independent variable. Is the independent variable continuous or categorical, right? So a continuous independent variable would be something like speed on a 100-meter sprint, right? That's a continuous variable because the numbers just run on until you press the stopwatch, right? If it's categorical, then that means that you've got distinct clumps of categorization. So apples are red or green, right? So that would be dichotomous. Sex is a dichotomous categorical variable. You're either, well, 98% of humans on the planet are either male or female, right? So sex is a dichotomous variable. Does that make sense? So it's relatively simple once you've had some practice to say, okay, my independent variable is continuous or categorical, okay? Then I want to define whether my dependent variable is continuous or categorical. And this is one of the reasons why I encouraged you to stick with one independent variable and one dependent variable, right? Because it makes the whole process of analysis so much more simple if you've only got one of each, right? It starts getting pretty complicated when you have two or three, okay? So the first column is my independent variable. Is it continuous? Is it categorical? If it's categorical, is it dichotomous? Right? It can be continuous and dichotomous, although that's starting to get a bit complicated. I'm not sure that any of you have a variable that's that complicated. Then once you've decided on your independent variable, you go to column 2, you decide on your dependent variable, and then you go to column 3, and it says, bingo, this is the type of statistical analysis you would run. So is it going to be a correlation, like an R? Is it going to be a t-test? Is it going to be an ANOVA or a multiple regression? Right? The last one there is a chi-square. Chi-square, I've never used a chi-square personally, because it means that your data is non-parametric, so it's skewed or it's kurtosis, it's not normative. I've been reading papers more and more where chi-square is being used. So I probably need to actually pick up a statistics textbook and learn a bit more about it. Don't worry about the bottom block as a master student. This is only if you have more than one dependent variable, right? So, and none of you have more than one dependent variable, so you can ignore that bit. Okay. So it's just an easy, you can start here. You know, if you identify the variables in the paper that you're reading from the purpose statement, you can check yourself, right? You can say, okay, let's see. I think then that the statistical analysis these authors will have used will be a t-test. And then you can see whether that's what they use, right? And that helps you practice with these ideas. Because they do take, you know, especially if you don't have a stats class. If I had my way, we would have a stats class on the degree plan. Because I think it's important. But we don't. So most of you are probably going, thank goodness. Okay? But it does make a difference with reading research if you have a little bit more grasp of what the stats mean. There are some really, really easy to read statistical books available, textbooks. There are some monsters that you don't want to touch with a barge pole. But if you look around, you know, you can find an easy guide that puts the stats into very readable language to understand. I have one on my shelf in my office, which, to be quite frank, if I hadn't had that book, I wouldn't have been able to finish writing my dissertation. It was a lifesaver, because when you look at a true stats textbook, it's like reading Russian. It makes no sense whatsoever. In your textbook, so not the APA manual, but in the actual textbook, there's also quite a lot of useful information. If you go to table 24.1, which is, I can't remember, it's way back here somewhere, analyzing quantitative data, is chapter 24. And they have some tables in this chapter that can also be very helpful, right? And, you know, I picked this book deliberately. Really, it's an undergrad research textbook. But the graduate research textbooks are complicated and they're hard going to read. And I wanted you to have something that would be useful, that you could refer back to, that would help you in your other classes when you're having to read research papers. So, you know, the language in this book is very readable. So chapter 24 is our quantitative analysis chapter, and they have some tables. So on page 324, they have a table that is characteristics of each level of quantitative data. So is it nominal? Is it ordinal? Is it interval? Is it ratio? Right? Who knows? I don't know this stuff off the top of my head. If I read that in an article now, I've got to go and look it up and remind myself what that means so that I can truly understand what's happening in the results section, right? Because I just don't do enough of it anymore to remember it off the top of my head. Let's see. Nominal data, their example is coding school subjects. So maths is coded 1, English is coded 2, science is coded 3, PE is coded 4. So this would be categorical data. So that's useful to help you with your reading, right? What I would say is always have your APA manual and this to hand when you're reading any research. The statistical tests, so one of the other documents I have up for you is this one. I don't know if you can see that heading in the dark. It's from another book, and this has a list of the common statistical analyses that you're going to see in the articles you're reading. So then you can come find this, and they've got a common usage kind of descriptive piece. So it helps you to understand why they're using that, what they're analyzing. This is not anything you want to try and learn, in my view, right? Because you've got the resources. Just keep them to hand. The more you read, some of it will just soak in, and you'll find yourself reading a paper going, oh, they're going to use a repeated measures ANOVA. And bingo, they use a repeated measures ANOVA. Just because you will, just because the more you read, the more you're going to absorb the kind of language that is used. Okay? But just keep this stuff around so that you can look it up when you need to. Okay? I would never say you got to learn this, right? Not as an HPE major. Some people might disagree with me on that, but I mean, I got through 3 statistics classes and a dissertation by being able to look things up and work out what the hell I was reading, right? So, if I can do it, you guys can do it. So that when you're reading, practice, right? And there are some on the cheat sheet. Practice classifying the independent variable and dependent variable so that you get the hang of that concept. Okay, shape of the data. Why do we care about the shape of the data? All right, so I'm going to have to try and do some drawing here for you. So, a bell curve, this is if you plot your data, right? So you've got numbers. So if we wanted to, we could plot them. If when you plot them, you have a bell curve, you lucked out. That's very happy making, because that makes things easier. All right, so a bell means that we've literally got our Y and our, sorry, it's very hard to draw with a mouse. Y and X axis, and our data looks something like that, right? So if I put a line through the middle, it's like one of those butterfly paintings that we used to do as a kid, right? You chuck loads of paint on one side of the paper and fold it over and rub it and then open it up and you got a mirror image. That's what a bell curve is. And what a bell curve tells us is what we would expect in a large enough population. so, thousands and thousands of participants, is that I have a few participants that are nah, and I have a few participants that are woohoo, and most of my participants are just like everybody else, right? That's what a bell curve says. Does that make sense?
Yes.
Yeah? So then, the next one is one that you do see quite a lot in kinesiology research papers. So the next one is called skewness. And skewness can be of two types. It can be negative or positive. And I'm going to show you a cheap way to remember which is which, because it took me quite a while to work this out when I was in grad school. So the data, instead of being this nice equal bell shape, comes out like this. Okay? That's skewed. And it's a negative skew, and this is where I'm going to give you the cheat, because it took me, I could not get my head around. I thought it was a positive skew because most of the people are on the positive. No. It depends on which way the long tail is pointing, all right? So if you add an arrow to the tail, it's pointing left. That's a negative skew. All right? If your data looks like this, that's a positive skew. And you'll see this mentioned when it impacts the type of statistical analysis the authors can run. Because if the data isn't bell-curved, isn't normative, then we have to do some work with the data in order to be able to analyze it fairly. Okay? And you don't need to understand any of that unless you want to. All right? If you want to, there are lots of stats books out there that will teach you more than that about it. But you really don't need to understand more than that. It just impacts the type of statistical analysis that will be used. Okay? And so then the authors have to say, when we looked at the data, it was positive or negative skewed, and therefore we did this. All right? And then the third one oops, I don't want that to be green. Go back. I want that to be blue like the rest of it. The third one is called kurtosis. And I haven't done anywhere near enough research reading in recent years, but I have to say that in grad school and since grad school, I've maybe come across kurtosis in a exercise science paper twice. But I do have to put the caveat in that I really have not done much reading recently, sadly. Oops. So kurtosis can be more or less peaked. Okay, so what that means is that my data looks like this, or my data looks like this. Okay? And as I said, this is the one that I've not really seen often. You see skewness quite a bit, particularly if they don't have a massive sample size, which often in our field you don't get these great big sample sizes. I know when I was looking, my dissertation was on preschool children, and the child development data, I mean, they have data sets of thousands of preschool children, you know. I got my hands on like 24 at the daycare that I was working with. So, you know, it's really, when you have that huge number, you would hope to get a bell curve. When you've only got 30 people, then you start to maybe get some skewed data because too many people are great, right? Or too many people are really bad at something, and you don't have this nice kind of average picture. Okay. Okay, and then some other language that you might come across, and as I said, even on the cheat sheet, it does talk about parametric versus non-parametric analyses. And again, I'm not suggesting by any means that you learn this. I am just trying to provide you with language and a little bit of explanation so that when you are reading peer-reviewed good quality research, you've got something to fall back on to try to, you know, because it can be, the formality of the language in a research paper can be overwhelming, right? It takes some getting used to. So that's all this is about, really. So parametric versus non-parametric. So parametric would mean that I have interval data, so that means that the variances between each data point are relatively even, right? And then that provides a normal distribution, so a bell curve, right? So if I have a bell curve, I can make the assumption that using a parametric test is okay, right? However, when those assumptions are not met, right, when the data points are all over the place and some of them are wide apart and some of them are right next door to each other, and I don't have this nice bell curve picture, then we have to use a non-parametric test like a chi-square. Okay? And there's another table in that chapter 24, table 24.2, which is where, that's on page 327. And again, it's just a tool that you can use. They're looking at appropriate tests for particular levels. So is it interval and normally distributed, or is it interval but it's not normally distributed, so it meets that assumption, but it doesn't meet the second assumption, it's skewed. So if it's interval data but it's skewed, what do I do? Right? Who the heck knows? That's why we have books. Okay? So we look it up. Or we go to the math department and we ask the stats person, but I don't know about you, but when I go and ask a question, I like to at least sound like I kind of know what I'm talking about when I ask the question. So I want to do a little bit of looking up to make sure I'm using the right verbiage before I go and ask the specialist, right? Because that's just, I just like to not sound like a blithering idiot. All right, so again, you don't have to learn it because you've got resources that tell you what you're going to do. And you may be thinking, well, I'm not going to write a thesis. I've already decided I'm going capstone class route. Well, you may change your mind, right? You may read a paper that you're really, really interested in that's gobbledygook because of all this stuff that you need to go and look up in order to interpret what the paper is saying, right? Or in 10 years' time, you might decide, I think I want to do another master's or a PhD. And then you're going to have to tackle stats, right? So just giving you the tools. The bigger the toolbox, the easier the job is, as my partner always says. If you've got the right tools, you can do anything. Okay. All right, so verbiage you should see, you don't always, but you should be seeing, is talking about the hypothesis for the study, okay? And we have two hypotheses, but really they're the flip side of each other, okay? So we have our research hypothesis, all right? So that's what, based on all my background reading that I've done before I go and run this study, my research hypothesis is what I think may happen, what I'm really hoping might happen, right? So that's called the alternative hypothesis. It's sometimes labeled as H1, okay? So in our field, that is often along the lines of that we're going to find a significant difference between two things or a significant relationship between two things, right? That's what I hope I'm going to find, right? The flip side then is called the null hypothesis, and that means that there is no difference, okay? And it's often labeled as HO, H naught, really, okay? So then you probably have to read this next sentence several times to yourself over the next few days for it to really make sense. What we want to do when we run our statistical analysis, we set our alpha, so we set our p-value, right? What is my level of significance? Am I going with 5%, 1%, 10%, right? What we want to be able to say from our results is that we can reject our null hypothesis. So we've got a double negative, right? I want to reject the fact that there's no difference, i.e. there is a difference, right? Negative and the negative makes a positive. positive. And so if I can reject the null hypothesis, then I can accept my research hypothesis. So again, it's all verbiage, right? It's all just language, and the more you can grasp the language, the easier it will be to read research. And it's worth putting in the effort, because research is flipping fascinating, right? Once you find something that you're interested, I mean, you can just spend forever reading these papers, right? At least I hope you're starting to think it's fascinating and not bored to tears, because that would make me sad. So here's our alpha, right? So my alpha represents my probability of the answer being true, right? And from a research ethics point of view, alpha has to be chosen ahead of time. You can't run your stats, see what you've got, and then go, ooh, if I make my alpha 0.1, I'm actually going to get some, no, that's cheating, right? So you have to decide ahead of time what your alpha is going to be, all right? So what alpha and P tell us is that the results, the difference that I find can be trusted, right? So we want the smaller the alpha, the smaller the P, the more trustworthy the difference or relationship is going to be. Okay? So then we use our alpha and our P to allow us to accept or reject. Right? So if P is greater than whatever we set alpha at, that means that we have to accept the null hypothesis and we did not find a difference between our variables. But if P is equal to or less than alpha, then we get to reject the null hypothesis, accept the research hypothesis, yay, and everybody goes home happy. Now actually, having to accept the null hypothesis isn't always a bad thing. Depends what it was you were testing, right? So if I'm testing 2 training programs, and I think going in, my research hypothesis is that training program A is going to be way, way better than training program B. And I run the study and I collect the data and I run the stats, and actually what I find out is that training program A is no better than training program B at all. They're both equivalent. But training program A would have cost heaps and heaps of money. Then I found out something useful, right? I don't have to spend that money because it isn't any better than the stuff I'm already doing, right? So having to accept the null hypothesis isn't always the worst case scenario. It's just that you go in with your research hypothesis and you've done all this reading and you're all excited about the study and you're like, I just want to find what I think I'm going to find, and then you don't, and it's a bit of it's like popping the balloon, you know, it's a bit deflating until you realize that actually what you found was quite interesting anyway, right? So what do we set alpha at, right? When you read kinesiology papers, P is usually less than 0.05, right? right? So that means that that alpha is 0.05 means there's a 95% probability that the difference is real and not by chance. Okay? And so typically with Knies stuff, you'll see a 0.05. If you look at, maybe she says, I don't mean this to be disparaging, but I know it's going to sound like that, maybe like sociology type studies, even maybe education studies. I don't read enough about education, so I don't know. They may set their alpha at 0.1, right? That means there's a 90% chance that the difference is real. Okay? Well, I prefer a 95% chance that the difference is real. Okay? Now, if you start reading something like medical journals, then they often set their alpha even smaller, right? They will set alpha at 0.01. And that means that if they find significance, there's a 99% probability that that is real and not by chance. Right? Well, that's really important because here I'm testing a drug, right? And I've got permission to test the drug, and so I've got volunteers. Some of them are taking the drug, some of them are going to be taking a sugar pill, right? Whatever. If I set alpha at 0.05, 95% chance that the difference, that when I say I find the drug works, right, because it meets alpha, that means I have a 5% chance of being wrong. That's a pretty big number when you're talking about a drug. Like, what if actually it gives people heart attacks? And it doesn't make them better, right? So, in certain lines of research, they're going to set P as small as they can because they want to be as clear as possible that the drug isn't going to kill anybody. Or maybe one person in a million. Right? Does that make sense?
Yes.
Yeah? Now, when you're reading our type of research, they'll set alpha at 0.05. So you'll see all the way through the stats that P, we found significance, open brackets, P less than 0.05. And sometimes they'll go on to say, when we look more closely, we still had significance at P less than 0.01. Right? They didn't set it at 0.01, but that means that the data is even stronger, and they want to point that out to you. Right? So occasionally they'll tell you alpha is 0.05, and then as you're looking through the data, you'll see P less than 0.01, and you're like, hey, wait, but they set it at 0.05. They're just pointing out that, this is even better than we thought it was going to be, right? Okay, so more verbiage that you might come across in your reading that will not be explained in the article. You're expected to know what they're talking about. All right, type 1 and type 2 errors. So type 1 and type 2 errors are connected to this idea of the research or the null hypothesis, okay? And a type 1 error means that I rejected the null hypothesis when actually the null hypothesis was true. So remember, the null hypothesis says there is no difference, right? So if I make a type 1 error, I'm saying there is a significant difference when in reality there isn't, okay? A type 2 error means I accept the null hypothesis when actually it's wrong. So in a type 2, we say there is no difference. Bummer. But in reality, there was a difference. Okay? A type 2 error is preferable because you're less likely to do damage making a type 2 error than a type 1 error. Particularly in our field where we're working with people and we're moving them and we're stressing them and we're doing all this stuff, right? It's much better to make this mistake than think that we've found programs that do something different when actually they don't. Okay. And then authors will often talk about the power. Sometimes you'll even see them discuss the fact that they ran a power analysis before they collected the data to find out the minimum number of participants they needed to make power. Okay. Power, if I have enough power, I'm very unlikely to make a type 2 error. Right? We want to increase the power and decrease the possibility of making errors. Okay. And then the last little bit that I wanted to go over is, I think it's really interesting. It's also something you don't always see in the research, and you'll get a feeling why as I go through this. I do have I think I've got a link. I've either got a link or a document. I think it's a link in that week 9 folder that discusses effect sizes further. So an effect size is, so we have significance, right? I set my alpha, I run the analysis in the software, it spews out paper, and somewhere on the paper it tells me P is less than 0.05. Yay. I have significance. I have a significant difference between the variables I'm looking at. Right? That makes everybody very happy. And many, many of us, me included, have published data on the strength of a significant difference. Okay? But when you transfer that into reality, okay, then what the statisticians would say that it can be significant without being useful or practical, right? So, let's go back to my training program idea. Training program A improved my 1 RM squat significantly better than training program B, right? But it improved my 1 RM squat by 5 kilos, or let's say 5 pounds, okay? Is that a practical significant difference? Is it a practical difference? Is it a useful difference? Is 2 kilos really a practical, useful change? Right? That's where we go to the effect size. Okay? So, if it's a really, really good piece of research, they will talk to you about the effect size, right? Because this means that not only did they find significance, but they found something that's actually useful, okay? So when we look at effect sizes, in general, there are a couple of other models, but the most common model that you'll see is that anything less than 0.2 is a small effect size. So if they report they had significance and then they report that the effect size is 0.2, that means, right? I got the significance, but really, does it mean anything in real life, right? Around 0.5 is medium, and anything more than 0.8 is a large effect size. This is woohoo! Right? If I get significance and I get an effect size of 0.8 or more, I am a very happy bunny. Right? No one is going to challenge that study if I can show data that comes out with those kinds of numbers. Right? So we go back to the idea of having power means that if an effect size exists, I'm more likely to find it with power, right? Typically, power means more people. Not always, it does depend on what the study is, but typically, power means more people, which, as I've explained earlier in the semester, that can be problematical in our kind of research. You know, having a true, random, large population, it is pretty difficult to get your hands on doing our kind of work. Right? Some other terms that you'll see for effect size, you might see Cohen's D or F, eta squared. Eta squared is similar to R squared, so any of those kinds of terms, when you see those, it means the authors are reporting the effect size as well as the significance. So often what happens when you read a research study that's a little bit weak, maybe, they'll report the significance and they'll completely ignore anything about effect size. You just won't see anything about it. You can get that published, right? But as the reader, you want to be a critical reader of research, right? You don't just want to read everything and go, oh, because it's published, it must be wonderful, right? So looking to see whether or not they discuss an effect size as well as the significance is one way of starting to become a critical reader, right? A critical thinker of the research that you're reading. And that, my friends, is all I have for you. It's probably enough, I would think. Unless you've had a stats class, in which case you're probably going, oh, I remember all that. So any questions, either on that or anything else that I can help with?
No, sounds good to me.
We are putting these lectures up on YouTube as well, which is why I have the other camera. So just for an FYI, you know, later in your degree plan, if you need any of this information, you can jump on our ENMU HPE YouTube page and watch this lecture all over again, just for fun. Because I think, you know, often, as with everything, you know, learning takes more than one time of hearing it, seeing it, trying it, right? We have to practice. So I like to make sure it's available for people to come back to. And if we leave it just in Blackboard, once they roll over, that lecture's gone, that recording's gone. And we're getting rid of Blackboard anyway this summer. So, yeah, I don't like to just rely on the recordings in Collaborate. Is there anything else?
So I'm gonna be honest and completely drop the ball on our assignment.
That's okay.
Do we?
You have no idea how many balls I've dropped this week.
Oh, I've got to get that done. Okay, anyway, regardless, do we have to fill out each one of those summary forms for each of the article?
Yeah.
Is that what I'm understanding?
Yeah, so what you're gonna submit, and Michelle, honestly, don't worry if you can't meet the deadline, because it's not like I'm not already drowning in grading that should have been finished 2 weeks ago, you know. So what you're going to hand in is one Word document, and that Word document will have your purpose statement, which, based on the feedback from midterm, you might want to tweak a bit or leave as it is, right? So you're going to have your purpose statement, and then you're going to have template number 1 for your first article, and then template number 2 for your second article, number 3, number 4, all in one Word document, so that I don't have to have 15 different documents open at the same time.
And these are they're the same templates we've been using prior for our articles?
Pretty much. If you look at it, I tweaked it a little bit. I changed it a bit because if you remember back, I said, like, I have you identifying the design early in the semester because that's something you should be able to start picking up, but it typically is not something you would put in a summary. So that row's gone, right? You've got the reference, the purpose, participants, the copy of the template. Let me just double check and make sure that it's open and that I'm not telling fibs here.
Yeah, it's there.
Yeah. It is a little bit different, so use this one. It's got slightly different grading on it. The word limit is changed to 250 from 300. Most of the other things I think are the same as the kind of guidelines that we had before midterm. I don't remember I can't remember when it's due. I think it's due Monday, right?
No, it says the 26th.
Oh, tomorrow?
Yeah.
Why did I do that? How silly of me. Yeah, no, don't worry, Monday will be fine. I've got, yeah, it's not gonna get graded this weekend. I'm working through all the other stuff. So, yeah, Monday will be fine. You know, and just, again, don't try to remember your APA format for your reference. use chapters 9 and 10, go line by, element by element, what does it say this has to, so that you don't chuck away easy points there, right? Think about one sentence for the purpose, one sentence for the conclusion. Those two can be copied exactly from the body of the paper. Do not use the abstract. Right? You've got to be able to locate those two things within the paper for yourself. Okay? But the rest of it needs to be summarized in your own words. Right? And be thinking about using full sentences now, particularly when you're looking at the data analysis and results sections, because the next version of the ANOBID, you're going to remove the template and you're going to hand in a paragraph. So you've got to start thinking about grammar. Okay? Does that answer all your questions?
It certainly does.
Does that make it better or worse?
No, it actually makes it a lot better. That took a huge weight off my shoulders.
Okay, good, good. All right. That I like to hear. And hopefully it won't, it's schoolwork, it's always like, oh, the sun's shining, I'd rather go outside for a walk. But I'm hoping that because you're reading papers that you've found on something you're interested in, that actually this won't be too onerous, that you'll actually quite enjoy it in a weird way, right? Give yourself time so that you can enjoy the process. I think that's part of the problem is we put things off until the last minute, and then it can't be fun because you've got a deadline to meet, right? So
I do have one question. I noticed one of the articles that I just read kind of goes into what my purpose statement is. So apparently that particular paper is filling the gap. So do I need to restructure the purpose statement? Or can I just...
Remind me what your purpose statement was?
Autonomous motivation for PE experiences like that affect adults, what they learn in PE, does that...
Oh, right, what they do in PE, does that impact their motivation to be physically active as they get older?
As adults.
Okay, and what's the purpose of the paper you're reading?
The purpose basically was the fact that there's 3 particular experiences that have been identified that cause allegedly long-term consequences where physical activity as adults is impacted, but there's not actually data backing up that statement.
Okay. Then I would say you're probably safe sticking with what you've got. You could always tweak it slightly to say, depending on what this other paper's saying, you could say which motor skills that are learned in PE impact physical activity in adults.
Okay, and could I possibly change it to just saying females?
Absolutely. Yeah, because there's tons, we got sadly more than enough proof that girls are less active than boys by about the age of 4, and that just gets worse and worse and worse as we get older, typically. right? So yes, absolutely. But there's been some really interesting research over the last few years looking at the fact that it isn't locomotor skills that drive physical activity. It's object control skills, which always is just like, if that would be really fascinating to pin down. But yeah, I think you're okay. I think because you're unlikely to find something that's just girls, I would think. Check if that paper that you're looking at has a reference list, and what's the date of that paper?
I believe, hold on, I've got it here, if my computer wants to cooperate with me. I think it's pretty recent. Wow, okay. I do not see the date on here.
Oh, here we go, 2013.
Okay, so look at the reference list, look at the authors. When you go into the library database, you could search by author name, see if they've done any follow-up studies since that one was published. And that you know, that kind of thing might make you feel a little more secure in your choice. Anything else I can help with?
The article I sent you, did you find any more information on it? The
Oh.
same press?
Jonathan, I have not had chance to open it yet. It's sitting there, I know it's there, I just haven't had a chance to open it. I will try to get that done this weekend and get back to you. I just had some administrative stuff jump up this week that wasn't expected, that's taken up a lot of time. So, Michael, did I answer your question that you emailed me?
I don't know if I emailed you a question. I did have a question though.
Okay.
About the connectivity to the Oh yes, you did email me back. Thank you.
Okay.
But I'm looking at some articles and they're not creating their own data. It's a lot of secondary data. Does that can still consider as participants if the research was already done?
I wouldn't, no. Unless the specific authors of, in my view, unless the authors of the paper specifically have their own participant pool, then no. The only caveat there is if it specifically says it's a meta-analysis. So in a meta-analysis, it's like a lit review, but the authors take everybody else's data and create a new database with it and run analyses on the new database. Now, they still don't have participants, but in order for the results to make sense, you might, in that case, you might want to say, you know, what the participant pool from all these other papers look like. Does that make sense?
Yeah, yes, that makes sense, yes.
But if it's a meta-analysis, it will tell you it's a meta-analysis.
Okay.
And then you'll know that that's the way to approach it.
Okay, perfect.
Okay? Okay. Well, if we have no further questions, we're done for today. Yeah, I don't think there's anything else I need to make sure you've got a hang of as always. Sorry, yes, go on.
There's one article I was looking at, it's more of a proposal to, for like medical insurance to pay for fitness trackers. Guess I'm gonna have to do away with that article because I don't really see a way to summarize it because it's not really any results or anything.
Right. Well, here's how I would approach it, right? You're going to need more than 4 papers at the end of the day anyway. If I was doing it, I would pick the 4 papers that I was the most interested in and were the easiest to summarize. Right? So, you know, that's just generally my approach. Like, don't make the path harder than it needs to be.
Makes sense to me.
Right? If you're struggling to put a group of 4 or 6 papers together and you need to use that article, then go ahead. But otherwise, you know, I mean, it's never a waste of time reading. And it's just more information about this topic that you're interested in. But that doesn't mean you have to use it for the assignment. Just take the easy path. You know?
I'll see you guys later.
Okay.
Okay.
All right. Have a great evening. Yeah.
You have a great evening, weekend, week.
Thank you. Yeah, and you. And do. Please try and enjoy the process. Otherwise, it's kind of a bit daft doing it. Try to make it as fun as you can.